Well, I'm hoping this will help rather than make things worse. So here's a video showing everything I did. First thing on Tuesday night was when I got home to wire in a 110 plug. Let's see, so that way, there you go. So you can see it's hooked up properly. And the machine will run on, was it 110, 220, or 440. So this should have allowed it to at least turn on. Took it over, plugged it into a known good outlet, which I'd actually just wired the other day. So anyway, plugged it in, turned it on. You do the switch in the back, then you hear a contactor inside somewhere near the switch fire off. A buzzing starts, which is to be expected since it's an inverter style machine. But no lights on the panel, nothing, no response to it. I'll bring you over here so you can hear the buzz yourself. And see that there's nothing on the panel. So next thought then was, okay, maybe there's a rat nest in there or a loose cable. Well, not rat, but mouse nest, loose cable, scorched circuit board or something like that. So opened it up. Unplug it so I don't zap myself. So opened it up. It was fairly clean inside. Some grit and grime, but not all too bad considering it would have been in around grinders and whatnot. Most importantly, there's no smell of burned electronics, no bulging capacitors, no scorch marks on any of the circuit boards. So looked fine. Let's see, a little hard to see here. But the display panel board does have a bit of a funny kink to it, likely on account of when this got hit. All the tracings looked good. So I don't know what quite to make of that, whether or not that's what's causing the display to not come up or not. But I believe the microcontroller that actually controls the machines on that board, so if there's a problem, that could be it. And over here this is the boost board. Again, no bulging capacitors, no burned resistors, everything checked out. At which point I turned to the owner's manual, which was less than helpful. It said if the machine doesn't turn on, check the plug. Not very helpful. Guy on Welding Web hooked me up with the technical service manual and testing booklet, which explains how Miller wants you to test the various components. Anyway, my background's in engineering, so that wasn't as necessary. But I did skim through it and followed its instructions. Anyway, that leads to where I am now, which is, pardon when I pick you up again, going through the pre-power checks. These are the tests done by service technicians prior to powering on the machine, just to make sure it's not something stupid like blown diode or something like that. This page is mainly concerned with making sure you discharge these two large capacitors because they'll hurt if you get hit with them. They're 450 volt, I think, what was it, 1500 microfarad. So, pretty big. Anyway, first up was the power control module, which is hidden down here. It's a little hard to see, but it's inside of this white block underneath this insulating screen and below the interconnect board. It's actually attached to this heat sink. Mainly what the power control module does is rectify the incoming voltage, create a DC voltage, and outputs it to the rest of the machine. So mostly what's involved there is checking the diodes. Ran through it 4 times. First time I went through all of the checks I could do, and when it still wasn't working, went back again with the same multimeter and then with 2 different multimeters just to make sure it wasn't my meter. Everything was checking out. Only goofy one was this guy, which the instructions actually say that some meters won't be able to handle this on account you're measuring 2 diodes in series. The other 2 meters I used are kind of crappy. I'm not surprised that it read those out of range, but the good meter read it as okay. Next up was the power interconnect board. More diode tests, and again ran through it 4 times. They all checked out okay. Boost control board, which is this guy over here. This guy. Which, again, more diodes. They all checked out fine. Should probably mention that before doing all this testing, I did pull all the connectors, tighten down all the screws, and pulled these 2 boards and reseated them, because sometimes you can get corrosion between the pins and the sockets down in here, and that'll cause funny things. Unfortunately, that didn't help. So, hence going on to doing this stuff. Then on to the inverter control board. Only ran through this one twice on account. I got fed up with it. But more diode checks. They checked out fine. Snubber board, which is on the bottom. I suppose I should show you that. Hold on. Okay. Down here we have the snubber control board, or IGBT snubber. There's some grime here, but I'm not quite concerned about that. It's on the bottom of the machine, and that's where all the grit kind of pooled and it gets hot. Yeah, I can see it just kind of adhering. But no bulging caps, no burned resistors. Boost board is also good. Transformers all look alright. So, not sure what to make of it other than to follow the pre-power checks on it, which was more diodes and some resistances. Everything was within spec. This page identifies secondary heatsink components. No, actually there were 2 things to test. Test the output diode, and that came in fine. Next page was troubleshooting table. The only one that applies is no weld output unit completely inoperative. So it says to make sure you have it turned on, replace any fuses in the circuit. There's no fuses in the machine, so that would have been my circuit breaker, which is fine. I had this lamp here was running off it as well, so it definitely had power. Check the plug, which I did, including taking off the 110 plug and putting on a 220 plug. That way it had two hot leads going into it and impossible to screw up short of getting ground wrong. No difference. And then I pulled the power switch and tested that out. It tested fine. Which then led to the troubleshooting circuit diagram, which is not a physical diagram, but a logical diagram, but it's neither here nor there. So basically it identifies 11 resistances that you have to check and 7 voltages. The resistances all checked out, and they're here: R1, R2, R3, R4, R5, 6, where are the others? 7, I don't know, they're on there. They all checked out just fine except for R1 and R11. Now R1 came in at 944 kilo ohm, should be 1.5 mega ohm. Thing is, that is actually, where is it? Over here. That's the fan motor. So the fan is seeing more resistance than it should, but the fan only comes on when the machine's in need of cooling, so chances of that keeping the machine from turning on at all are very slim. So I moved on. R11 36.6 is right here, and that's the thermistor that's attached to the heatsink, which feeds into the fan control. So when this thermistor gets too hot, that's what turns on the fan. Again, that's dependent on room temperature. So it's what? 6 kilo ohm out of nominal. Shouldn't be a problem. But then that led me to doing the power on test. Hooked it up to the power, turned it on. V1 here, 27 volts. V1 is the power across the fan. I get nothing. It's 27 volt DC. There's 0. V2, 24 volt DC, same as V3. They are over here. Oh, actually, I could show you where they are. Because they are right here on the inverter control board. So this guy here, that's the fan cable. So it wants 27 volt DC when the machine's powered on, right there. Because the circuitry that turns the fan on and off is actually built into the fan casing. I get 0 on that. V2 and V3 are, where, it's hard to see here. RC6, 1 and 3, and 2 and 4. Here's RC6. Again, I get 0 voltage on that. V4 is on the other side of the machine. That is a secondary winding off of the main transformer, which is the guy back in there with purple. So hold on a second. Okay, so V4, here we have the main transformer back in there. V4 is a secondary winding that provides 173 volts AC to what? PC6 is the boost circuit, which is this guy over here. That's the boost board. So one end of that winding is here on the relay contactor. The other end is over here on the boost board with this guy. Should be 173 volts AC. I get nothing. V5, I can't actually test on account the display doesn't come on. So I can't set the weld output, which means I can't know what that voltage will be. And V6 and V7 are over here. Where is that? So that is off of... Okay, that's this guy. So here's this Hall device. Comes into this gray one. And that gray one flips around to the other side. Onto the inverter controller board. Which is here. And I'm supposed to see, what is it? Negative 15 volt DC and positive 15 volt DC on the red and black wires relative to ground. And again, I get nothing. So that means either the inverter controller board is bad, the power interconnect board is bad, or the power module is bad. I can't tell which. But I'm very confident at this point that it's not something obvious, like a loose connection, or anything I did. It just didn't turn on. It's doing the same thing it had been since I got it home. Hope that helps. If you have any questions, I'm sure you'll let me know. So, anyway, thanks.